Imagine that we did not need a tester at all. Imagine that there is a circuit and a test, and it has some built-in self-test. It is capable of testing itself. What if the advantage then will be that we do not need to buy testers, upgrade them, maintain those testers. All that problem will be eliminated altogether. Okay. So, this will eliminate the need to buy testers, maintain them, okay. Those testers are also going to require a lot of maintenance, right? They will need a lot of space to store, right? They will need space, they will need operators to operate them. There is a training that we have to provide to operators, which is expensive, right? They will draw a significant amount of power, they may need repairs. So, all of this is expenditure. Okay. So, we can bring it all down to 0 if the circuit could test itself. That means we add some extra logic here which can perform this self test. Okay. What is the price we pay? Price of BIST. It is not free. Okay. See the say CUT plus additional area. Okay. So, additional area means it will hit your yield, right. So, therefore, yield will be affected. Number 1, right. Remember, the yield is sort of it decreases quickly with the area. Okay. It is sort of exponentially decreasing with area. A small increase in area will have a serious impact on the sort of the yield. Okay. Yield is the number of chips that we can that are good, that are defect free. Okay. I may have explained this before also. So, if I have a wafer, right, if I have the area of the chip is small, right, then I can make a lot of chips. And there will be some defects. So, in this example, I may have lost a small number of chips. Let us say I lost 1, 2, 3, 4. Okay, but the total number of chips I made is very large. So, let us say we had 1, 2, 3, 4, 5, 6. So, approximately we have about 30 chips, let us say. Okay, so 4 are bad. So, 26 out of 30 is our yield. In reality, this won't be such a small number. In a modern situation, we have wafers which are very big. Okay, modern wafers are about 30 centimeter in diameter. Okay, so their area will be 2 pi r square, right, pi r square. So, pi r square, where r is this 15 centimeters. So, you can calculate the area of a wafer, and the dies are getting smaller and smaller. So, you will this number actually is much larger. Okay. So I have just shown a very trivial example. Okay. Whereas if I took the same wafer and now my chips are bigger, I may still lose the same number of chips for the defect ones. Okay. So let us say we lost 4 chips because of defects, but now how many chips are made? Maybe only 16 chips are made, right? Only 16 chips are made, and out of them 12 are gone. Okay. So this will be the yield. So you will realize that this is very poor. Okay, we are losing a lot of revenue here because only 12 out of 16 chips are good, whereas here 26 out of 30 are good. So what does it show? If I increase the size of the chip, okay, I pay for it in terms of the poor yield. Okay, so that is the reason why any increase in area is something that we are worried about. It impacts the yield. What else? When you add extra area or extra gates, your power dissipation will also go up. Right. So that is the other negative impact. Right. Then the design of the chip will be more difficult. Design effort will be higher. So we will need more people to design, and that will make it expensive. We will need more tools, and different tools will be required. Earlier we were using ATPG tools, etc. Now we will need BIST tools. Okay. Those tools will also cost money. Okay. They will also cost money. So in terms of cost, in terms of power dissipation, and even the impact on timing will be there. See, we are adding additional circuitry, so more wires. Okay. So as a result, a negative impact on the performance. Okay. So performance may also be impacted. So there is some price to be now paid for BIST. Okay. Nevertheless, when you compare the cost that we are saving in terms of not having to purchase testers, not having to do all of this that I mentioned, right? You don't need any big area for maintaining those testers. You don't need the operators to maintain those testers, all that stuff. Everything is inside the chip. Okay. So there is a comparison. Okay. So in some cases, logic BIST makes a lot more sense, right? It depends on the complexity of the chip. So one has to actually look at the specific case and figure out whether logic BIST will make sense or not. Okay. The other thing about BIST is you can continuously test or continually test. Okay, that is also a very important point. So let me make that separately. With BIST, you can test continually. What does that mean? Okay. See, we talked about manufacturing test, right? So this is the manufacturing test. Once the chip has been purchased by the customer and it is being used, in the tester based testing, right, there is no way to really test the chip, isn't it? I mean, you may apply some functional tests. Okay, so maybe functional testing is required, right? So, for example, okay, if let us say somebody is making a microprocessor, okay, the vendor, the semiconductor vendor who sold the microprocessor, that person will apply tests, manufacturing tests. Okay, that person knows how this microprocessor is built, what are the gates which have been used, right? All the, so it's a white box test, meaning we know the internals. But once it goes to the customer's hands, the customer doesn't know, what is inside the microprocessor. So the customer will do what is called as black box test. The customer uses the functionality of the chip to test the microprocessor. So this is a situation when we are using, when we are not using BIST. But imagine that if BIST was being used, this is without BIST. With BIST, maybe we can do manufacturing tests here and reject the bad ones, right? Once the customer has the chip in their hands, the BIST circuitry is still there on the chip. So the BIST can still be enabled. So the customer can also apply BIST. Okay. So he can enable BIST. The customer can enable BIST. And this can be done many times. Where is this useful? See, the chip may the chip may have been good here, right? When it was sold to the customer, it was a good chip. But over a period of time, it may develop faults because of reliability problems. Okay, so it may age. The chips will age, and as a result, they may become faulty. So if we continually test, then we may be able to detect the reliability problems. So suppose we test it every day. Okay, so let us say we have a car. Okay. In that car, there is a lot of electronics. Okay, maybe there is a car to there is an electronics for controlling the engine of the EV electric vehicle, and there are a lot of microcontrollers for controlling the pressure in the tires, operating the windows, in car entertainment, so many different things, right? Now, every time the ignition is sort of turned on, right? Every time the car is started, maybe some built-in self-test can be run. Okay, so that is called in-field testing. Every day we do it, or every time the car is started. What is the advantage? If the chip has failed because of some reliability issues, remember the cars operate in very harsh environments. Similarly, robots. Okay, so there may be a robot. Okay, I have written a robot like this, but I mean it could be an industrial robot. Okay, it may look somewhat different. It may be an industrial robot. I don't know how to draw it. It does something. Now these operate in very harsh environments, high temperatures, lot of dust. Okay, so temperature, dust, temperature variations. It may be very cold and then very hot, right? Vibrations. All of these may cause the chip to develop some faults. The package may fail, right? Transistors may fail inside. So we will be able to do in-field testing if we have enabled BIST, if we have used BIST. Okay, this is the reason why. Okay, for automotive testing and industrial robots, etc., BIST is recommended. In fact, BIST may be mandatory. Okay, so BIST is very useful, very useful in these industrial robots, industrial electronics, automotive electronics, etc. Okay. So that is the importance of built-in self-test.